Algebra 3, Chapter 7, Section 3, Solving Trigonometric Equations. To solve equations, we're going to use familiar algebraic techniques whenever possible. We'll combine like terms, we'll factor, we'll do operations on both sides. The primary goal is to isolate the trig function on one side of the equation and then solve for the variable. Because the trig functions are periodic, there are an infinite number of solutions for each equation, so we're going to form a general solution that will show the pattern for all possible solutions. And when trig equations follow a quadratic model, we basically have two options, just like we would with a quadratic equation. We can factor, or we can use the quadratic formula. It sometimes can help to substitute a variable for the trig function before using either method. In other words, let's say we have sine squared of x. Just make it x squared, and then we can go back and replace the x with the sine of x later. Now we're going to also do functions involving multiple angles, and what that means is that rather than sine of x or cosine x, we have sine of something times x, like sine of 3x or sine of 5x. And when we solve these, we're going to solve the equation for whatever times x, 2x or 3x, and then divide by that number. So let's try this example. We're going to start really easy. All you have to do is take the equation tan x minus square root of 3 equals 0, put in pi over 3, and show that it works or that it doesn't work. Do that for these two problems. Pause the recording, give it a try, and resume to check your answer. Okay, so all of these do work. Now we're going to solve these equations, and these are, what you're going to do is you're going to get the trig function by itself. In the case of the one on the left, the cosecant x by itself. In the case of the one on the right, the secant of x by itself. You will then, once you have that, do an inverse function to get the answer. So pause the recording, give it a try, resume to see how you did. Okay, so what we did was we added 2 to both sides and then divided by the square root of 3. So the cosecant of what is 2 over square root of 3? Well, that's pi over 3. Now, because pi over 3 works, but if you add 2 pi to that, if you go all the way around the circle, you get another answer that works. And if you go around the circle, you get another answer that works. We're going to say pi over 3 plus 2 pi n. In other words, what it's saying is pi over 3 plus every trip around the circle and back, whatever that gives you. 2 pi over 3 also works because cosecant is a reciprocal of sine. Sine is positive in the second quadrant. Pi over 3 in the second quadrant is a reference angle for 2 pi over 3. And notice we have the same thing, plus 2 pi n. For the secant, we add 4 divided by 3 and take the square root. We have to consider both the positive and the negative here. So we have pi over 6 plus pi n and 5 pi over 6 plus pi n. Now you may be wondering why not 2 pi n? Well, pi over 6 takes care of it in the first quadrant, and it also will, when we add 180 to that, we get it in the third quadrant. So that's what the pi n is, or when we add pi to that. Basically, because it's plus or minus, we're going to have one angle in each quadrant that works. So what you could do is list the 4 angles, the one for each quadrant, and put plus 2 pi n. But what they've done here is a little shorter. They've given the angle in the first quadrant, and then they've said plus pi n, because if you add pi, you get the one that's in the third. And then they did the same thing. They gave you the one in the second quadrant, and then said, okay, if you add pi, you get one in the fourth quadrant. So it's a little tricky. I'm probably going to be more concerned with getting those initial values rather than the general form, but give it a try and see if you can get the hang of it. All right, try these. We're still not getting too complicated yet. The one on the left, notice that we have the sign of 2x. That 2 is not going to come off until after we figure out the angles. Notice on the right, this has been factored for you. You're going to set the two factors equal to 0 and solve. Pause the recording, give these a try, and resume to check your answer. So we solve for sine of 2x, and we get plus or minus 1 over the square root of 2, which is plus or minus square root of 2 over 2, which is pi over 4. So the sine of, the inverse sine of square root of 2 over 2 is pi over 4. It's also 5 pi over 4. And then notice we put the plus 2 pi in. But that's 2x, and it's plus or minus, so we actually have them in each quadrant. So you'll see there we have 2x equals pi over 4 plus 2 pi n, 2x equals 3 pi over 4 plus 2 pi n, 2x equals 5 pi over 4 plus 2 pi n, and 2x equals 7 pi over 4 plus 2 pi n. That's the 4 quadrants because it's both positive and negative. Then what we do is we divide each of those by 2. So we end up with pi over 8 plus pi n, 3 pi over 8 plus pi n, 5 pi over 8 plus pi n, and 7 pi over 8 plus pi n. And then they combine them and a little bit more too. I'm not worried about you combining it all the way down. So if you get that last line, I'll be second to the last line, I'll be very happy. On this one, just sine equals 0 or sine equals -1. Sine is 0 at multiples of pi. So at 0, 1 pi, 2 pi, 3 pi. So it's just n pi. It's -1 at 3 pi over 2 plus 2 pi n. Now try this one. What you need to do on the left one is you need to subtract the cosine from both sides and then factor out the cosine. On the one on the right, you need to consider it a quadratic. You can treat it like x squared minus x minus 2. Use the quadratic formula or factor. This says find all the solutions in 0 to 2 pi, so you don't have to do the plus 2 pi n thing here. Just give the answers that are in one trip around the unit circle. Pause the recording, give these a try, and resume to check your answer. Okay, so like I said, factor out the cosine, subtract cosine first, factor it out, and then solve each of these. Cosine is 0 at pi over 2 and 3 pi over 2, and we got plus or minus 1. That's going to be at 0 and pi. For this one, it's going to factor into, if you treated it like x, it'd be x minus 2 times x plus 1, which would be secant x minus 2 times secant x plus 1. Solving for those, we get that the secant of x is 2, which occurs at pi over 3. That's where cosine is 1/2 at pi over 3 and 5 pi over 3. And secant of x equals -1, which happens where cosine is -1 at pi. Okay, give these two a try. The one on the left you're going to treat like a quadratic. The one on the right is really tricky, so I'm going to give you a hint. What you're going to do is you're going to square both sides. Give it a try. Challenge yourself. See if you can work it out. It is a tricky one. It is a challenge. Again, you're only looking for answers between 0 and 2 pi, so you don't have to mess with the general form. Pause the recording, give these a try, and resume to check your answer. Okay, again, factoring, we get that 2 cosine x minus 1 times cosine x plus 1 is 0. Setting each equal to 0, we have cosine of x is 1/2 and cosine of x is -1. Cosine is 1/2 at pi over 3 and 5 pi over 3, and it's -1 at pi. Like I said, the second one's a challenge. What you have to do is you have to square both sides, which is a mess. And when you square it, then what you do is you've got stuff in terms of cosecant and cotangent. So what they did is they changed cosecant squared of x to cotangent squared of x plus 1. The reason they did that, now we can combine like terms. We got 2 cotangent squared of x plus 2 cosecant x cotangent x, and they subtracted the 1 and got it equal to 0. Then they could factor out the cotangent. In fact, they factored out 2 cotangent. I probably wouldn't give you one this tricky. This is a really tricky one, and you have to kind of pull a fast one in order to solve it, but you see there are the final solutions. You do need to check for extraneous solutions, because whenever you square it, that can cause some extraneous solutions to be thrown in there. If you put 3 pi over 2 into the original solution, it will not work. Okay, let's try these two problems. Pause the recording, give them a try, and resume to check your answer. So add 1. Tangent is 1 at pi over 4. So 3x equals pi over 4 plus n pi. Now, why are we doing n pi? Because tangent has a period of pi. Divide by 3, and we get pi over 12 plus n pi over 3. For the second one, we have the cosine is square root of 2 over 2, which is, again, pi over 4. And what you can do, it's pi over 4, and it's also going to happen at 7 pi over 4. So we have those plus 2 pi n. and then we multiply by 2 to get our final answers. Okay, find the x-intercepts of this graph. In other words, set the equation equal to 0 and solve. Pause the recording, give it a try, and resume to check your answer. And you see, we solved this pretty easily. We got pi x over 2 equals 3 pi over 2 plus 2 pi n. And then we multiply both sides by 2 and divide by pi. And that gives us 3 plus 4n. And in the graph itself, the intercepts are at -1 and 3. I know you're thinking, well, I can count and see that, but you know, it could be a little off, so you need to be careful and you need to do the algebra. Quadratic formula to solve this equation. What you want to do is treat this like 12x squared minus 13x plus 3. You can use the quadratic formula, and then instead of x equals -b, it's sine x equals -b plus or minus, etc. Pause the recording, give it a try, and resume to check your answer. And you see how we put everything in there. And you really just have to do it on your calculator, and you can confirm it by graphing. Now use the inverse functions, find all the solutions. This one you can use the quadratic formula or you can factor. Pause the recording, give it a try, resume to check your answer. And here they were asking only for answers between 0 and 2 pi, although they gave the general form. So on this one, you'd really need to, what they want you to do is write it in terms of the inverse function. So what you see there, I would be more inclined to have you just put it in your calculator. Okay, one more example. You're going to use inverse functions where needed to find the solutions. Again, we're going to be factoring here, so pause the recording, give this a try, and resume to check your answer. Yeah, the first one you have to pull a little trick. You've got to replace sine squared with 1 minus cosine squared because you want everything in terms of the same trig function, if at all possible, and in this case definitely. So we do that, and then we distribute the 2. We get it in the order we want. I would then divide everything by -1. They pulled it out. I would just divide it out. And then factor or use the quadratic formula. For cosine of x equals 1/2, you have 2 solutions, pi over 3 and 5 pi over 3. For cosine of x equals 2, you have no solution because a cosine cannot go above 1. On this one, we're going to factor out the common term of secant x, and again, set them equal to 0. Secant x will never equal 0, so there's no solution to that part. And secant x equals 4, where the cosine of x equals 1/4. And so what they're saying here is it's going to be the inverse cosine of 1/4 and the negative inverse cosine of 1/4 plus 2 pi. Again, I would just as soon have you put it in your calculator and come up with a decimal answer.